Hey, chemistry. Hey, I'm getting ready for bed and I've got my toothpaste here. I'm going to brush my teeth. This is the one that my dentist recommends that I use. So it's a fluoride heavy toothpaste. It's got 1.1% sodium fluoride. And I went to the back of the tube to look and see, and they didn't tell me what kind of a percent that was. They still just say 1.1. So I went to the safety sheet online and I found out that it's 1.1% weight percent, and this little W per W, it means weight per weight. And so what that is, there's 1.1 grams of sodium fluoride per 100 grams of toothpaste. So that's our traditional weight percent. It's 1.1 grams out of the total solution, or out of the total amount of toothpaste, 100 grams of toothpaste. And so that's like our traditional out of 100%. You'll also notice that they listed just the fluoride concentration, and they used ppm. Let me get rid of that red circle. They said it's 5,000 ppm fluoride, and what that means is 5,000 parts, and that parts could be maybe grams of fluoride out of a million grams of toothpaste. So a ppm is very similar to a percent, but instead of being out of 100, it's out of 1 million. So it's a good way to express small concentrations. So 5,000 out of a million grams of toothpaste are fluoride. And if we're never going to use a million grams of toothpaste probably in our entire lifetime. But if you say wanted to deal in a smaller quantity, you could take this down to grams, 1 gram. If you move the decimal place, let's see, clean this off. If you move the decimal place 1, 2, 3, 4, 5, 6 places to the left, you gotta do the same thing in the numerator. 1, 2, 3, 4, 5, 6. Fill it in with zeros. So it turns out it's 0.005 grams of fluoride ion, right? Fluoride ion out of 1 gram of toothpaste. So for every pea-sized dollop of toothpaste I use, I get 5,000ths of a gram of fluoride ions on my teeth. Okay, so again, that's parts per million. And then I wanted to talk about one more thing, and this is what the little question on your week 7 post or week 7 category is. It's going to ask about something, a W per V, and that's a weight per volume. And what this means is this is grams out of 100 milliliters. So it's another way to express concentration, but this time it's a weight per volume. So instead of out of 100 grams, it's out of 100 milliliters of solution. So this is a common way sometimes chemicals are mixed, especially if you have a dry chemical and being mixed into a solution. They'll do the weight of the dry chemical out of 100 milliliters of solution. And so I know I don't have a toothpaste example, but if I was to do a quick example, let's say how many grams of NaCl in, let's say, 500 milliliters of a 7.5% weight per volume solution. So if you had a saline solution, which is just salt water, you had 500 milliliters, that's half a liter of it, and it was 7.5% weight per volume sodium chloride, then the way you'd set this up is, well, and the question's asking how many grams of sodium chloride is in that solution. The way you'd set it up is you'd say 7.5 grams out of 100 milliliters, there's our 7.5%, is equal to X grams over 500 milliliters. So there's our proportion. So 7.5 out of 100 is the same as something out of 500. If you're Mr. Patterson here, you cross multiply and divide. You're just solving for X, right? So I'm just going to multiply by 500 milliliters. These cancel. So I got to do that on my calculator. 5 divided by 100 is 5. 500 divided by 100 is 5. And 5 times 7.5, 35, I think it comes out to 37.5. So I end up with 37.5 grams of NaCl in that solution. So again, this guy means weight per 100 milliliters versus this means weight in grams per 100 grams of solution. So just different ways to express concentration. Hope that helps. There's a couple questions like this on your test. So I'll leave a practice question in this week's weekly category. So good luck, and I'll talk to you guys later.